Hello everyone, myself Hanasha. So today we are going to discuss few topics of complex numbers. So let us start with circular function. So from Euler's formula, e raised to I theta is equals to cos theta plus I sin theta. And e raised to minus theta is what? Cos theta minus I sin theta. So from these two equations, we can obtain the value of cos theta using elimination method. So if I add these two equations, you will get cos theta is equals to 1 upon 2 e raised to I theta plus e raised to minus I theta. And sin theta as 1 upon 2i e raised to I theta minus e raised to minus I theta. This is obtained by subtracting these two equations, right? Now, if z is equals to x plus iy, if we have complex number in Cartesian coordinates, right? Then cos z is equals to 1 upon 2 e raised to iz plus e raised to minus iz. And sin z is equals to 1 upon 2i e raised to iz minus e raised to minus iz. So you have to remember these two formulas, right? And these are called circular functions of complex number. Okay, so now let us solve examples. So we have to prove that sine inverse z is equals to minus I ln iz plus square root of 1 minus z square, and then we have to find the value of sine inverse minus I. Okay, so let us assume sine inverse z as y. Therefore, z is equals to sine y. Now, this is a circular function and we know the formula of sine y in sense of complex numbers. Therefore, we can write our z as e raised to iy minus e raised to minus iy upon 2i. Okay? So now let us take this on this side. Therefore, 2iz is equals to, when from the numerator we will take out common e raised to minus iy. So what will remain? E raised to 2iy minus 1. Fine. So now we will take this also on this side. So 2iz e raised to iy. If we take this on this side, it will become plus iy, right? Is equals to e raised to 2iy minus 1. Now let us take this on this side and make one equation. So this will be e raised to 2iy minus 2iz e raised to iy minus 1 is to 0. Now we can find the roots of this given equation, right? And we'll obtain the roots of what? E raised to iy. Therefore, how can we obtain the roots of e raised to iy? The formula will be minus b plus or minus under root b square minus 4ac upon 2a. So now here your a is 1, b is what? Minus 2iz. Find from this. And c is minus 1. Okay. So let us put all these values. Therefore, your e raised to iy is equals to 2iz plus or minus under root of, it will be 4i square z square, right? 4i square z square minus 4 into 1 into minus 1. So plus 4 upon 2a. Now let us modify this and write our simplified answer. So e raised to iy is 2iz plus or minus. Now this will, I square is what? Minus 1. So this will be what? Minus 4z square. So we can take out 4 common. So we will have 2 under root of 1 minus z square upon 2. Now take out 2 common and cancel it out. So answer will be what? Iz plus or minus under root 1 minus z square. Now let us find the answer of y. Therefore, your y will be equals to what? 1 upon I times ln iz plus or minus under root of 1 minus z square. But 1 upon I, if I multiply and divide by I, this in the denominator I will have I square, which is equals to what? Minus 1. So our final answer is minus I ln iz plus or minus under root 1 minus z square. Okay, so we have proved this result. Now we have to find the value of sine inverse minus I. So this y is what? Sine inverse z. Okay, so this we have to replace by minus I. Therefore, sine inverse of minus I will be equals to, here in place of z, just put I. So you will get your answer as minus I ln minus I square plus or minus under root of 1 minus I whole square. So let us simplify this. So answer will be minus I times ln. Answer of I square is what? Minus 1. So we will have plus 1 plus or minus. Now this I square will be what? Minus 1 and minus minus plus. So here we will have under root 2. So the answer of sine inverse of minus I is this. Okay. So now let us solve one more example. Now we have to prove that tan inverse of z is equals to I by 2 log of I plus z upon I minus z. Now first let us assume our tan inverse z as y, right? Therefore your finally z is equals to what? Tan y, which is equals to what? Sin y upon cos y. And we know the formulas of sin y as well as cos y. This is 1 upon 2 I e raised to iy minus e raised to minus iy, and upon 1 upon 2 e raised to iy plus e raised to minus iy. Now these two will get cancelled out. So finally your z is equals to tan y is equals to what? E raised to iy minus e raised to minus iy upon I times e raised to iy plus e raised to minus iy. Now let us take this I on this side. Therefore, you will have Iz as e raised to iy minus e raised to minus iy upon e raised to iy plus e raised to minus iy. Fine. Now what I will do is multiply and divide by I over here. So I will get finally in the numerator I square. So answer of I square is what? Minus 1. So minus z upon I. This is what we are getting from here. Is equals to this e raised to iy minus e raised to minus iy upon e raised to iy plus e raised to minus iy. Now first take this minus sign over this side. Therefore this will be, therefore z upon I will be equals to minus e raised to iy plus e raised to minus iy upon e raised to iy plus e raised to minus iy. Now let us apply componendo and dividendo. But I want I first. You can see over here. So what I will do? I plus z upon I minus z. That is denominator plus numerator upon denominator minus numerator. So here also I have to apply the same technique. So here we will have e raised to iy plus e raised to minus iy. Now write this numerator. So minus e raised to iy plus e raised to minus iy upon. Now again same technique. So e raised to iy plus e raised to minus iy. Now we have to do minus of this. So here it will become plus e raised to iy minus e raised to minus iy. Now let us see what gets cancelled out. This gets cancelled out, and in the denominator this gets cancelled out. So finally what is remaining? We are having 2e raised to minus iy upon 2e raised to plus iy, right? 2 will get cancelled out, and from here we can say that I plus z upon I minus z is equals to e raised to minus 2 iy. Now this can be written as minus iy is equals to minus 2 iy is equals to ln I plus z upon I minus z. Okay, now let us bring this on this side. But before that, multiply and divide by I. Always you do this procedure to make I square. So I square will be minus 1. So what will remain? Only 2y upon I is equals to ln I plus z upon I minus z. Now just take this I in this numerator and 2 in the denominator. So you have obtained your desired result, that is y is equals to I by 2 ln I plus z upon minus z. or log, whichever is convenient to you, right? But this y is what? Tan inverse z. So tan inverse z is finally I by 2 ln I plus z upon I minus z. Okay. So now let us go to the next topic, that is hyperbolic function. If z is a complex number, then cos hz is equals to 1 upon 2 e raised to z plus e raised to minus z, and sin hz is equals to 1 upon 2 e raised to z minus e raised to minus z. So from these expressions, other hyperbolic functions can also be obtained using tan hz, that is sin hz upon cos hz. Cosec hz is what? 1 upon sin hz. Similarly, sec hz is 1 upon cos hz, and cot hz is 1 upon tan hz. Thus, you have to use these two formulas to obtain following results. Now, there is one important thing. Sine hyperbolic of minus z is equals to minus sine hz. Similarly, cos h of minus z is cos hz. So now, let us find the relationship between circular and hyperbolic function. So we have to prove that sine iz is equals to I sine hz. So in order to prove this, I will use the formula of circular function, that is of sine z. So formula is 1 upon 2i e raised to iz minus e raised to minus iz. Now I want what? Sine iz. So I will replace my z by iz. So replace z by iz. Okay. So on replacing, we will get sine iz is equals to 1 upon 2i, and in bracket what we will get? E raised to I of iz minus e raised to minus I of iz. Okay. So now this can be written as 1 upon 2i. Here it will be e raised to I square z, but the value of I square is minus 1. So we will have e raised to minus z. Okay. And here also, here it will be e raised to minus I square z. But I square is minus 1, so what will remain? E raised to z. Now, in order to obtain the formula of sine hz, first I will take out minus sign common, right? So I will have minus 1 upon 2i e raised to z minus e raised to minus z. Now let us multiply and divide by I. So in the denominator, what will happen? I square, but its value is what? Minus 1. So finally what we have derived, that sine iz is equals to, so minus minus will get cancelled out. I times we will have e raised to z minus e raised to minus z upon 2, and value of this is what? Sine hz. So we have proved that sine iz is equals to I sine hz. Next, let us prove similarly that cos iz is equals to cos hz. So again we will use a formula of cos z, that is e raised to iz plus e raised to minus iz upon 2. Fine, now again replace z by iz. Okay, so on replacing, what we will get? Cos iz is equals to e raised to, I am directly writing I square z plus e raised to minus I square z upon 2. Now the value of I square is minus 1, so replace by that. Therefore, cos iz is equals to e raised to minus z plus e raised to z upon 2, right? And this is what? Cos hz. Fine. Now next, let us prove the formula of tan iz, that is equals to what? I tan hz. So first let us prove this only, then move on to this. So we know tan iz is what? Sin iz upon cos iz. But what is sin iz? It is I sin hz, right? And this is what? Cos hz. These two formulas we have just proved. So this can be written as I tan hz. So we have proved that tan iz is what? I tan hz. So the first identity is proved. Now let us take this I on this side. So what we will get? 1 upon I times tan iz is equals to tan hz. Okay, from this. Now let us multiply and divide by I. So again you will have I squared. Answer will be what? Minus 1. So we have proved that 10hz is equals to minus I 10iz. So second identity is also proved. Now there are few formulas in order to separate real and imaginary parts of the following identities. So the first is of sine x plus or minus iy. So it is a simple formula of sine alpha plus beta. So what we can write? Sin x cos iy plus or minus cos x sin iy. But here we have to apply the relationship between circular and hyperbolic function that we have just studied. What we have studied, sin iz is equals to what? I sin hz, and cos iz is what? Cos hz. So whenever you have sin iy, you have to replace by what? I sin hy, and wherever you have cos iy, you can see here we are replacing by cos hy. So we are obtaining the formulas of sin x plus or minus iy in form of hyperbolic function in order to separate real and imaginary parts. So this is the real part and this is the imaginary part. Similarly, you can obtain the formula of cos x plus or minus iy. So the formula is cos x cos iy minus plus sin x sin iy. But what is cos iy? It is cos hy. And what is sin iy? It is I sin hy. So you can see we can now separate the real and imaginary parts. So using these two formulas, you can obtain the formula of 10x plus or minus iy, right? Similarly, you can obtain the formula of sin h of x plus or minus iy. This also you have to apply the formula of sine alpha plus or minus beta and simplify further, right? So all these formulas you can obtain easily using these two formulas and the formulas of sine alpha plus or minus beta or cos alpha plus or minus beta. Okay, next. Again, there are some formulas of hyperbolic functions that you have to remember. These are simple formulas of sine to theta, cos to theta, but in form of hyperbolic functions, right? So all these formulas you have to remember. Fine. So now let us study inverse hyperbolic function. So if x is equals to sine hu, then we can write this as u is equals to sine h inverse x, and this is called sine hyperbolic inverse of x, where x is real number. Similarly, we can obtain cos h inverse x, tan h inverse x, cot h inverse x, sec h inverse x, and cosec h inverse x. Okay. So now let us study few examples. So we have to prove that sin h inverse x is equals to log x plus square root x square plus 1. So what we will assume first, sin h inverse x as y. Therefore x is equals to what? Sin hy. So now we know the formula of sin hy. It is e raised to y minus e raised to minus y upon 2. Now let us simplify this. So take this 2 on this side. Therefore 2x is equals to e raised to y minus e raised to minus y. Now take this e raised to minus y common. So we will have 2x as e raised to minus y into e raised to 2y minus 1. So finally take this also on this side. So 2x raised to y is equals to e raised to 2y minus. Now bring this on this side. Therefore we will get one quadratic equation in form of e raised to 2y. So e raised to 2y minus x, 2x e raised to y minus 1 is equals to 0. Now we can obtain the roots of e raised to y using the formula minus b under root of b square minus 4ac upon 2a. So here your values of a is 1, b is what? Minus 2x, and c is minus 1. Put these values in this formula. So e raised to 2, y is equals to 2x plus or minus under root of b square will be 4x square minus we will have 4 into 1 into minus 1, so plus 4 upon 2. So from this we can take out 2 common, so 2x plus or minus 2 under root of x square plus 1 upon 2. Take 2 common, So finally e raised to y will be x plus or minus and root of x square plus 1. Right? So final answer of y, that is what? Y is what? Sin h inverse x is what? ln x under plus or minus under root of x square plus 1. So we have proved our required identity. So now this you can solve by yourself using the assumption cos h inverse x is equal to what? Y. Therefore x will be cos hy. Now we know the formula of e raised to cos hy, that is e raised to y plus e raised to minus y upon 2. And now solve this further using the previous example only. Right? Now let us move on to our last example, that is we have to prove that tan h inverse x is equals to 1 upon 2 log 1 plus x upon 1 minus x. So now again assume tan h inverse x as y. So your x will be what? Tan hy. What is tan hy? Sin hy upon cos hy. Put the formulas of sin hy. It is e raised to y minus e raised to minus y upon 2 upon cos hy is e raised to y plus e raised to minus y upon 2. These two will get cancelled out. So finally your x is equals to e raised to y minus e raised to minus y upon e raised to y plus e raised to minus y. Here we can write 1 and now apply componendo and dividendo. But what we have to do, denominator plus numerator, because we want 1 plus x. Therefore 1 plus x upon denominator minus numerator. So 1 minus x. So write in the RHS also in this form. So e raised to y plus e raised to minus y plus e raised to y minus e raised to minus y upon. Again subtract. So e raised to y plus e raised to minus y minus e raised to y plus e raised to minus y. So now these two will get cancelled and from the denominator these two will get cancelled. So what will remain? 2 e raised to y upon 2 e raised to minus y. These two will get cancelled. So finally 1 plus x upon 1 minus x is e raised to 2y. Therefore, log 1 plus x upon 1 minus x is equals to 2y. So your y, that is equals to what? Tan h inverse x is log 1 plus x upon 1 minus x. Okay? And here 1 upon 2. Okay? So I hope you have understood throughout the session. Thank you for watching.